The 10 frame was introduced in kindergarten and somewhat used in first grade. But it wasn't until the summer after first grade that I taught Allie how to go from this to this.
What's 0 plus 4 equals?
4.
What's 2 plus 2 equals?
4.
1 plus 5 equals?
6.
5 plus 5 equals?
10.
4 plus 2 equals?
6.
My name is Mimi Samsoneth, and you're watching How Allie Learned 10 Frame for Math Fluency on One Mom's Perspective.
How many is all that?
10.
That's correct. Why? Because it's a...
It's a 10 frame.
That is a 10 frame.
I'll take you through some step-by-step demonstrations so that you may see how teaching the 10 frame can effectively contribute to your child's learning. Doubles up to 10, addition up to 10, and addends of 10.
How many is that?
Mom.
After identifying 0 as nothing on the 10 frame, we started with one red circle counter in the 10 frame. It was indeed easy for Allie, but the point to this exercise was for Allie to see that the number 1, represented by the red counter, can be placed anywhere instead of belonging in just one particular spot, similarly to the fact family's concept.
How many is that?
2.
Good. How many is that?
2.
Good job. Does it matter where it is?
Yes.
No, it does not matter where it is. It's still...
It's still 2.
That's right, it's still 2.
The other point to this exercise was to introduce Allie to the addition math that can be seen and stated in equation form with just counters.
How many is that?
2.
That's right, this is 1
1
plus
plus
1.
That is correct. You got everything correct.
You did get everything correct.
After 1, the same was done with 2 counters, but the counters were not just red. The yellow would represent the other numerical data in an equation. The combination of 2 counters were also easy for Allie to follow. After 2, the same was done with 3 counters, and so on.
How many is that?
3.
Let's do equation. 1
1
plus
plus 2
equals...
equals 3.
That is correct. 1. What is 3 plus 1?
4.
Right, what's 3 plus 2?
3. 5.
What is 3 plus 3?
6.
That's right, what is 3 plus 3?
6.
You got it. 3 plus 3 equals 6. What's 3 plus 4?
7.
You got it. What is 3 plus 4?
7.
However, the 3 and 4 counters, or combinations of 3 and combinations of 4, were the toughest for Allie to follow because more counters in the 10 frame would mean more combinations on top of combinations just learned. So after 0, 1, and 2 counters were understood, we took our time mostly with the 3 counters, then the 4 counters.
3 plus 3 equals 7. Oop, I made a mistake.
It's okay.
3 plus 3 equals 6. I don't say 7, J. I need to pay attention.
Reinforcements and repeat recitals were needed. As Allie went through this exercise of visualizing the different combinations on the 10 frame, she was referred back and forth to recognize the addition math problems as well. Seeing the math both on the 10 frame as she saw it in the addition math problems combined visualization with recognition. Soon, she began to memorize, but not without first having understood, visualized, and recognized what she memorized. And that is key to long-term learning math concepts.
I think you got it. Allie, the 5s are very easy for you, correct?
Allie already knew multiples of 5s, though that was not necessary to learn the 10 frame. However, feeling most comfortable and being able to visualize the most with 5 as taking up one row in the 10 frame facilitated Allie's learning of math with 5 in it, whether it's doubles 5, which is the same as 2 5s in addends of 10, or addends added to 5. Allie's ability to visualize 5 plus in the 10 frame was the best advantage she had to recognizing much of the math up to 10.
To look at this and remember it in your mind, okay? Yeah. So when you see plus 5,
Plus 5.
that means the top row of the 10 frame.
The 10 frame.
Can you see that? Can you see 5 on the top row of the 10 frame?
Yeah, top
Yeah.
10
5 plus 1 equals
equals 6.
5 plus 2 equals
7.
Allie also understood the math doubles fact. Being able to recognize those doubles enabled Allie to memorize doubles up to 10.
Here's your doubles. 2,
2.
4,
4.
6,
6.
8,
8.
10.
10.
Are those your doubles?
Yeah.
Yeah, just like this. 3
3
plus 3
plus 3
equals.
equals 6.
Good. That's your doubles.
There's your double.
Although Allie already knew the addends of 10, the 10 frame exercise reinforced her memory with visualization. If she didn't already knew the combinations of 10, she could have learned it using the 10 frame, as she's learned combinations of other numbers up to 10.
10. 0.
That's your addends of 10. How many is that? How many reds?
9.
That's right. How many reds?
8. 2.
Yeah.
By process of elimination, Allie knew addends of 10.
7. 3.
Good job.
She was able to best visualize with 5. She understood fact families and was able to quickly learn the 0, 1, and 2 in the 10 frame. So, the most challenging for Allie was to learn the combinations of 3 and the remaining combinations of 4. In 2 weeks' time, Allie was able to repeatedly with confidence state the answers to math addition problems up to 10 correctly. When in doubt, Allie could check her answers with other methods, such as this.
4 plus 2 equals 6.
Before Allie wrote any answers, the exercise only involved her stating the answers. I removed all distractions, including taking the time to write answers, until she was comfortable in her thought processing and correct in all her answers.
5 equals 6.
Good job.
5 plus 5 equals 7.
Depending on what your kids already know, they would take needed time to learn the combinations they do not yet know.
4 plus 2 equals 6.
Yay! You can do all this by yourself, honey.
Taking them through the practice strategies in this video without skipping any numbers will result in math fluency up to 10 through visualization, recognition of patterns, and in part, memorization of the combinations learned in the 10 frame. Along the way, they could also learn the concepts of facts families, addends of 10, and doubles fact if they haven't yet already learned those concepts well. Thanks for watching.